and give them some time to get in because I know we have sessions beforehand. So I'll give them like a minute or two grace period.
Perfect. All right.
Total grace period here. But I will give them a little time to get here because I know directions and all that. People can get lost. Yeah.
People can get lost.
People can get lost, it happens all the time.
Yep.
But I think we've had some really good sessions for the day.
Oh my
So I
goodness. Amazing ones. Yeah.
really, really good sessions for the day. I'll just give them a few minutes to get in. Oh yeah, everybody's waiting for this session. Oh wow, I wonder why.
Because the superstar Sanya is on it.
Oh boy.
That's why.
She's awake now though. She wasn't awake this morning.
Yeah.
She is awake now, hopefully. And everything, the brain is totally functioning so we can answer all of your questions. But we'll get started on this side because I know we have like quick cutoff times. So, like, I'm so excited to be here with Greg. In case you missed it, it is a prerequisite for you to have this book to enter this session. So, make sure you have this book when you're entering this session, just as a, letting you know that, that's the only prerequisite that we have for LRVS is that you have that book for this particular session. So
Very nice.
I am going to get us started with this video that we have with Greg and we are answering a lot of questions in it. So have some fun with it and enjoy.
Hello and welcome to Lubrication Reliability Virtual Summit 2023 Europe and Middle East Edition. I am Greg Livingstone and I am pleased to be making this presentation with Sanya Mathura, and this is regarding our recently published book on varnish called Preventing Turbomachinery Cholesterol, The Story of Varnish. So today we hope to answer 4 key questions. The first is we're going to have a little discussion on varnish testing. Secondly, we'll discuss a little bit about oil color and varnish color. And thirdly, we'll go into what other potential markets where varnish is a problem. And finally, we'll see if we can answer the question, will varnish actually be formulated away? So to kick things off, Sanya, let me ask you, there are many lab tests out there. What are the primary lab tests that can be used to detect the potential for a lubricant to form varnish?
We have such a large variety of lab tests, but if we were to think about the 2 primary ones that we can use to actually measure the potential of an oil to varnish, I would definitely go with your MPC test and your ultracentrifuge test. Now, none of these tests should be done as standalone tests because sometimes there are always exceptions to the rules. And we would want to support these 2 tests with maybe an ISO particle count test and maybe even a gravimetric patch test. So what I would try to do while we're trying to stay within primary tests, I would also have some supporting tests as well. There has been a lot of potential with the IMPC patch test that is by Focus Labs in Thailand. I believe it's called the SMPC test with Polaris Labs. That has actually shown a lot of promise for the future in terms of, finding out a little bit more about these types of tests and if they can be the primary test for your oil to determine if they have the potential to varnish. So I think that would be my answer, MPC and the ultracentrifuge test.
Excellent, great answer, Sanya. Let me ask you, how do you see varnish tests evolving here in the coming years?
I think what will happen in the near future is that we always need a lot of input from the oil analysts. So what they see in the lab, what they see in the field. So I think the only way that we can really evolve is if we have that input from users and from people who are dealing with the equipment in the field, helping us to sort of bring everything together. But I think in terms of the actual tests themselves, we may get some more precise ways of, detecting the different modes of degradation, which of course we love to talk about, and maybe even interpreting the different colors on the patch or the type of deposits. So hopefully we get a lot better at doing those things in the near future, and the types of tests that we use can actually support that.
As we well know, varnish is well documented in the turbomachinery space. Let me ask you, are there other applications where one may run into varnish?
Varnish is, of course, well documented in the turbomachinery space. We wrote a book on it, so definitely, definitely well documented. But I think one of the main reasons for that is that we spend a lot of time in this space because there are a lot of critical applications that we can't afford for those applications to go down. And those were some of the first that actually saw varnish. But we are seeing varnish appear in industrial oils, in some gear oils, in some jet engine oils, the hydraulic oils, heat exchangers. Now, a lot of times varnish will form once you have the right conditions. So I think that, you know, a lot of times we will see varnish occurring in some of these other applications because the types of conditions are conducive to varnish.
Well, what knowledge can be applied from the turbo machinery space that we've learned here over the last couple decades into some of these other applications?
Of course, we can apply some of the information that we learned from the turbo machinery space because that was our learning grounds. That was the place that we, spent a lot of time researching in and trying to find out more about varnish. I mean, of course, there's still a lot that we don't know about varnish, unfortunately. But I think within the turbo machinery space, a couple of things that may have helped us in the past is actually trying to mitigate the varnish. And we have we've come across so many different types of technologies. We have the resin filtration technologies that we've used in turbo machinery space, but I don't know how well that will work in like an industrial gear oil that has a higher viscosity, because that's one of the limitations that it may have. So that's one of the things that we need to be wary of. Now, another way that we could mitigate varnish would be using these oil soluble cleaners. Now, those are the ones that they don't affect the additives, they don't impact on the performance of the oil. So they can be applied to different areas, such as your hydraulics, the gear oils. So they should be able to be applied without any sort of impact. So I would say taking that knowledge from the turbo machinery space and sort of applying it to hydraulics, industrial gear oils, some of the other areas that we are seeing varnish come up in, that would definitely be things I would want to carry across. Questions for Greg? We always get this question about if the oil color is related to varnish. Now we want to know what you think about that.
Oh, that's a great question. Yeah, and you're right. That's a very common question. And oil color is not directly related to varnish. But if you look at all the different things that may cause an oil to change color, contamination is clearly a big one. Oxidation or thermal degradation are also things that can cause the oil to change color. UV exposure, radiation, even exposing it to radiation in a nuclear power plant. So there's many potential causes for the oil to change color. But a lot of people think that since the MPC test is actually measuring the color of deposits on the patch, that there should be some correlation to the actual color of the oil, and there is not. We have many, many examples of nice, clear looking oil with a very, very high varnish potential, and inversely, black looking oil with a very low varnish potential. So there's not a direct correlation between the two, but if you see a change in color of the oil, it's signifying something is going on, and certainly warrants some extra oil analysis and some extra attention.
What about the different colors of varnish? There are some very pretty colors. There are some very interesting things that we find on the MBC patch. Now, what can you tell us about these different colors of varnish and what actually causes some of these, very vibrant colors?
Yeah, it's really interesting, Sanya, to look at all the various different colors we see. Often, most people assume varnish is a golden color or a brown color, but we see red thrown in there. We see tan, beiges, grays, sometimes orange, some bright colors, often black. But then we get to some more exotic colors like blues and purples and greens. So we see a wide range of different colors of the deposit chemistry. And we actually see evidence of this both on the MPC patch and actually the deposits that are right in the system. So some of the different factors that may determine the color of the deposit. Firstly, we look at the chemistry of the deposit. Is this derived from the mineral oil or the synthetic base oil, or is this coming from one of the additive components? The temperature of the reaction is a big one. In general, the higher the temperature reaction, the darker the varnish is. So on an extreme example, we could look at, say, microdieseling, which is a very, very high temperature event that will create submicron carbonaceous particles that are black in color, and over time, as these accumulate, you'll not only have black silky or silty type materials, say in valve bodies, but you'll also have a black patch. We've seen some patches that are as black as night, unbelievably dark. So temperature of the reaction is one, and then contaminants, and both water and dirt and other contaminants that may ingress, and gas as well. Gas can also cause some unique reactions to take place. So those are some of the factors that go into the actual color of the deposit. Now, I would say a couple of my favorite colors, blues and purples. Often those color deposits are derived from a specific type of amine antioxidant that will react in a special way and create this beautiful purple hue that we often see. And then another color is green, and we've seen green deposits sometimes in bearing surfaces. Sometimes we see some bright green patches. This is often caused in polyol ester type fluids. One of the degradation products is a phthalate that is green in color, but we also do see this in mineral oils as well. So wide range of colors. The scale of the MPC test when interpreting these various different colors remains the same. And we're looking at the total change in the total amount of color bodies on the surface of the membrane. But the color of the varnish can give you a clue as to the chemistry or actually how this the oil is degrading and how this deposit formed.
Do you think that varnish can be formulated out of your turbine oils in the near future, given the rates at which, we're evolving with technology and, all of these great things?
Will varnish be formulated away? That's a good question. So I can tell you that we've been running our turbine oil performance prediction test. We call it the top test for the last 10 or 15 years. And over the years, we've tested dozens of different formulations of oils. The first time we ran this test, we established a 6-week test period. And we thought, at 120 degrees with an iron copper catalyst and air bubbling through this should kill most oils over the course of 6 weeks. So let's monitor what happens over this time frame. And what we found actually in the first test that we ever did, one of the oils was a group 1 formulation, and it did not make it to 6 weeks. After 4 weeks, we could not get oil to pass through the MPC patch. We had a huge amount of cake material on top of the patch, and so in the course of just a few weeks, that oil passed, but that oil failed pretty miserably. But most oils after 6 weeks had high varnish potentials. You could start to see some pretty significant chemical reactions. The antioxidants had depleted. So that's originally how we were running this test. Now we run this test at 12 weeks, and we see many new formulations are going out to 12 weeks. without showing significant signs of deposits, was still having a very strong oxidative stability at the end of the test. I would love to be able to speed this test up, but what we have found is that if you increase that temperature above 120 degrees, you start to create some new degradation pathways that are not necessarily representative of actually what we see in the field. But unfortunately, we are running some tests now that are 18 weeks out, and we still see a couple of formulations that after 18 weeks in this test are still doing really, really well. So the bottom line is we are seeing a pretty significant trend to formulating turbine oils that are very, very long life, that are low deposits, and the difference between today's generation of turbine oils and yesterday's older generation is really, really significant. There's still a lot of differences between different formulations today, but if I was looking at a crystal ball and would say, are we actually going to formulate varnish away from turbine oils? I could see that happening here in the future, in the near future. I would say we're not quite there today, but we're definitely on that trajectory. There's still going to be some high temperature zones and high temperature deposits. For example, shear stress deposits are as a degradation mechanism that will be challenging to formulate an oil around. But if you're just looking at strictly oxidative degradation in a turbine oil, I definitely see a future here where we are no longer having to deal with varnish and it will be formulated away.
So what do you think? We talked about the, varnish mitigation technologies. What will be the future of those varnish mitigation technologies if it is that we don't have varnish in the oil anymore? It's been formulated out. How can that work in the future?
The future of varnish mitigation technologies. That's a good question, since we actually have seen a brand new industry evolve here over the last couple decades. So what's the future of these technologies if in fact varnish is going to be formulated away from say turbine oils? Well, I still think there is a bright future. So the first change that I think will happen is that users will start to use these technologies proactively instead of reactively. And I would say most times right now, people assume they will not have a varnish problem. They likely have been sold an oil based on a spec sheet that says the oil has been specially formulated to mitigate varnish and prevent any deposits from happening. So they already have this level of comfort that they're not going to have varnish, and then suddenly they do. And they're reacting and trying to find money in their capital budget to purchase a special filtration equipment or other type of technology. I think in the future, people are going to be much more proactively just installing this technology so that it's just an integrated part of their contamination control system. So why would they do that if in fact varnish may be formulated away from an oil? Well, actually, not only are varnish mitigation technologies or varnish filtration technologies in particular, not only are they removing oil degradation products, but they're also removing some of the reactive products that consume antioxidants. So if you look at how an oil degrades, and this I would say is a very simplistic approach, but you have the initiation phase of oxidation, it's creating some radicals. These radicals will then go and react with the antioxidants and cause more antioxidant radicals and intermediary byproducts, which will also react with new radicals. Essentially, if you have the ability to remove some of these radicals, in essence, what you're doing is you're preventing that from reacting with the antioxidant, and ultimately you're extending the life of the oil. So if you look at the range of varnish precursors, all of the kind of the initial ones in the initial initiation phases of oxidation, those are all significant antioxidant consumers. And if you have the ability to remove those, the life of the oil can be extended. In laboratory tests, we've shown that you can extend the life of an oil by at least 50% just by adding filtration. In the field, actually, we've seen even greater results than this. So this technology is not just removing and preventing varnish from happening, it's also helping to extend the life of the oil. And I think that's another big trend that we see in the industry, is that people want their oil to last longer. Ultimately, there's a movement towards fill for life oils, that you don't actually have to change your oil. You can just treat your fluid in service, in situ, remove the negative components, add the positive components back, the sacrificial additive components, and you're able to extend the life of the oil several orders of magnitude. And I see a lot of these varnish mitigation technologies being an integrated part of this process of having long oil life. So that's a first trend I see. Proactive instead of reactive. The second trend that I see is the increased use of solubility enhancers. One of the benefits of solubility enhancers, and again, not all solubility enhancers are created equally, but the ones that are formulated for long-term use, they're really simple to add. So it's just if you have a 50 liter system or a 50,000 liter system, it's the same concentration. You would typically put in, say, 3% of a solubility enhancer and have long-term protection against varnish. But it also helps with some unique degradation mechanisms such as shear stress deposits. And also the technology can be more easily used in other applications. And Sanya, you just talked about other verticals and other applications where we see varnish. This is, I think, where solubility enhancers can play a pretty significant role. So those are the trends that I see. Overall, I think that even though varnish, oil formulators have done a phenomenal job of making better formulations, ultimately, having a technology permanently installed that not only helps ensure you from having deposit issues and helps ensure a better reliability, but something that also is actively extending the life of the oil, makes a lot of sense for everybody. So that's my little crystal ball view of where I see the industry going. So that wraps up our presentation for today. I just want to say that this has been our third installment of our presentation around our Turbomachinery Cholesterol book, and what Sanya and I have been calling our virtual book tour. So it's been actually a lot of fun to put this together, and it was even more fun in writing this book with Sanya. So big thanks and shout out to her. Thank you very much for listening, and I hope you enjoy the rest of the conference.
All right.
All right.
Now that was interesting, if I do say so myself.
We may
I
be
know we had,
biased. I'm not sure. We may be
I
a
may
little
be
bit biased.
biased, but not so much. I know we had some questions come in while we had the video going on. And the first was from Dr. Quick. Um, I know Greg wanted to answer this live. One of the questions were, do different types of varnish with different colors need different ion exchange resins? That's an interesting one. So I'm gonna pass it over to Greg for him to answer that one live.
Yeah, that's a really good question. So, and actually, I just want to tie in Alessandro's comment actually into this answer. So he mentioned that they often see a blue or greenish varnish when you have an accidental mixing of turbine oils or corrosion or a vapor space inhibitor or corrosion protective, some kind of preservative in the oil. We have also seen this, and just coincidentally, early week in Poland, I was given a case where this oil had a lot of heavy varnish, and we were able to remove and lower the green varnish through our ESP media. That was not using a standard, or that was using our standard media, but if in that case the corrosion inhibitors are slightly acidic, and when they react with the turbine oil to make this green color, it all move no resins. Am I breaking up?
A little bit.
Okay.
Yeah.
Okay, my apologies. Okay. So that's a quick answer. They can be customized, but we have seen our standard resin will work pretty well in most cases.
All right, that was a good answer. And then I know we have as well Munieva. Please let me know if I pronounced that correctly. He was
Mhm.
asking about what was the signal of the green color for the chemistry. And I think you kind of mentioned that a little bit in your answer just now.
Yeah, so there's one other that he also mentioned that we mentioned in our fluid learning course on this.
Yes.
That was a phthalate that came from degraded polyol ester fluids. So
Oh, yeah.
that also is a nice, actually a pretty great course in swimming as well.
Yeah, it is. And I think we have one more with Alessandro asking if the TOPP will be standardized as an ASTM standard, you know?
So yes, the short answer is yes. I will say that when I first started the MPC, the work group to make MPC test a standard, it was 2006, and it did not become a standard until 2012. So it was 12 somewhat painful years for that test to become standardized. The top test is going to be much quicker. It's going to be an appendix on ASTM 7873, which is a dry toast test because it's the same oxidative environment. And I would anticipate certainly within the next 12 months that'll be a standard that has already passed the first subcommittee test. So great question. That before long, I think will in fact be an ASTM standard. Thank you very much. Great question.
Finally. And I think that one is a little bit easier compared to the ones that we've had to go through in the past where we had a lot more waiting time. So, technology evolves, and so too do our standards and all of these different types of tests that we do. So I think that's one of the things that we need to make sure of going towards the future, just having our baseline set correctly, having those fundamentals in place, and definitely, trying to figure out what we can do to evolve. Because if we don't evolve, then what happens then? So I think that was it for all of the questions that we had.
I think there's one more
And
that may have just come in.
oh, I missed that one.
Um,
Oh,
yes,
Elchan.
on the So yeah, this is a question on the what some people call the soluble MPC test. Um,
Mhm.
it was a process that was originally developed in Thailand, was Focus Labs, and Polaris has an iteration of that right now. Um, I think it remains to be seen. We did some early tests with that in the early 2000s. We did a fair number of tests with this, and it we had some challenges trying to correlate it with MPC. It doesn't actually need to be correlated with MPC. It could be an early indicator and it could be a value. But I would say that a lot of people are running this test now. And so this is something that we are investigating to see if it can help us identify some problem ones where maybe the traditional kind of MPC test isn't as predictive.
We hope
Great
that
question.
helps. That is a really good question because I think we're also looking towards what else can we do? You know, we're having Varnish. How can we help detect it earlier? What are different things that we can do? So definitely a good question. I'm glad we're able to answer it. So now we have 1 more minute with you all before you all get a slight break until we have our next session where Greg and I will be on a panel discussion with two other amazing people. So if you have any other questions, make sure and send it to us in the panel session because we're going to be talking about, the future of condition monitoring. So that may be a very interesting session as well. And so far, thank you all so much for being with us and joining us throughout the day. And I think that's it from our side.
All
Yeah.
right. Thanks,
Yeah.
everyone. See you in the
So
panel discussion.
we will see you all soon.
All
Bye.
right.